Hello everyone, my name is Ravi Yangwar and today I'll be teaching refrigeration cycle. In the previous lecture, I have briefly discussed about the basic laws of refrigeration which are applicable to refrigeration system. In this lecture, I'll be covering what are the major components of refrigeration system or cycle and what is the refrigeration cycle. Let us start with the first topic, that is what are the major components of refrigeration system or cycle. They are evaporator, compressor, condenser, expansion valve. When these components are connected together according to their respective function in such a way that you are able to achieve some desired effect or desired output with the help of refrigerant is known as your refrigeration cycle. Again, I'll repeat the definition of refrigeration cycle for better understanding. When the components like evaporator, compressor, condenser, expansion valve are connected together or arranged together according to their respective functions in such a way that you are able to achieve some desired effect or output with the help of refrigerant flowing inside the pipelines is known as refrigeration cycle. Let us understand the individual components of refrigeration cycle in detail. Let us start with the first component, that is evaporator. Evaporator is a shell and tube type heat exchanger in which the liquid refrigerant is flowing inside the tubes, and outside the tubes or in the shell your hot air, your heated air is there on the surface of the tubes. Now what happens at the outlet of your expansion valve, the liquid refrigerant is having low pressure. When it enters the evaporator, it enters the evaporator means it is entering inside the tubes of the evaporator. So liquid refrigerant which is there inside the tubes will absorb the latent heat of hot air or heated air. That latent heat, what it will do, it will vaporize, it will convert your liquid refrigerant into vapor, which will be having your low pressure and low temperature. So according to the first law of refrigeration, the first law of refrigeration says all liquids while evaporating absorbs latent heat of vaporization. So at the outlet of evaporator you are getting a refrigerant vapor which is having low pressure and low temperature. So this refrigerant vapor you cannot send directly to the condenser. Why? Because every refrigerant has some particular condensing temperature and pressure. So you need to increase the temperature and pressure of that refrigerant vapor so that it can be condensed. So what you are doing, you are putting a compressor inside the system so that you can increase the pressure as well as temperature of that refrigerant. So a refrigerant which is having low pressure and low temperature is entering inside the compressor. So compressor is a mechanical device which is used to increase the pressure as well as the temperature of the refrigerant. At the outlet of the compressor, you will be getting a refrigerant vapor which will be having a high pressure and high temperature. So you can send directly to the condenser. So condenser is also a shell and tube type heat exchanger in which if it is a water cooled condenser, your water will be going inside your tubes, and in the shell or outside the tubes your refrigerant vapor is having high temperature and high pressure will be there. Now this this condenser you can divide into three parts: top part, middle part and bottom part. So top part of the tubes are responsible for removing the superheat of the refrigerant vapor. Middle part of the tubes is responsible for the condensation of the refrigerant vapor, and like if any refrigerant vapor is left, so the bottom part of the tubes will be responsible for the subcooling of your refrigerant vapor. So this is how your condenser works. I'll explain what is superheating. Superheating is nothing but the difference between the superheated temperature and the saturation temperature of the refrigerant. At the outlet of the condenser, you are getting liquid refrigerant which is having high pressure. So you cannot send a liquid refrigerant which is having high pressure directly to the evaporator. Why? If you send directly a liquid refrigerant to the evaporator, your evaporation will not take place. So what you are doing, you are reducing the pressure of that liquid refrigerant. How you are achieving that reduced pressure? You are sending the liquid refrigerant to the expansion valve. This expansion valve is nothing, it's a throttling device which is doing two functions. What are the two functions? The first function is it reduces the pressure of the liquid refrigerant, and the second function is it controls the flow of refrigerant going inside the evaporator. Again, I repeat, this is a very important part of your refrigeration cycle, expansion valve. It controls the flow of refrigerant going inside the evaporator, and it reduces the pressure of the liquid refrigerant. So at the outlet of the expansion valve, you are getting a low pressure liquid refrigerant, and then it will again enter inside the evaporator. I hope I must have clear detailed explanation of all the components of refrigeration cycle. So there are two sides. One is low pressure side, another is high pressure side. So I'll explain the low pressure side. See, in the outlet of your expansion valve till the inlet of your compressor will be your low pressure side. Now I'll explain the high pressure side. From the outlet of the compressor to the inlet of the expansion valve will be your high pressure side. I'll explain with the help of a diagram. You can see this from the outlet of your expansion valve till the inlet of your compressor, your low pressure side, and high pressure side is from the outlet of your compressor till the inlet of your expansion valve is a high pressure side. Thank you so much.